everyone. Welcome to this bi-weekly PR review club. And today we'll be reviewing the PR number 32587, which is basically opened by me. And it this is actually a change in the functional test, especially in the mempool test, and to actually use the proper reorganization pattern. Okay, so first we'll see what is actually a chain reorganization. So if we see in the Learn Me a Bitcoin, given nicely. So if we see this figure, just increase the size. Yeah. So if you see, then suppose we are at the block 850K. Okay. So our node is actually at the chain type 850K, and after some time we are getting 850,001, and this is actually the active chain. Suppose we have received this block from our peers, and this will be the uh, current chain tip. Then after 10 minutes, we'll be having another block. Then after again, we'll having the another block. So this is actually the current active chain. Okay. So what happens is suppose in reorganization, the chain is reorganized to the chain which has the maximum cumulative proof of work. Okay. Suppose some peer is sending like a chain of blocks more than this active chain. Okay, here he or she or the node is the peer is sending more than three, for example, four. I've taken for reference 10. I'll tell you why I've taken 10. But as for suppose the peer is sending us the four blocks. Okay, then what happens is our node will actually change the current active chain to this one. Okay, that is actually reorganization. We are changing actually the current active chain to the another chain. Okay, because this one has the more proof of work. Or basically, you can say it has more blocks. Uh, Again, I mean, this should be valid. Okay, this one should be actually connected to this 850K, or else this won't be actually valid, and our node won't be validated. Okay, this our node will actually validate all this whether this chain is actually active or not. So let's go to the PR, and this is actually the PR. Okay, so what happens is, yeah. So if we go to this issue, while reading this PR number 32516, and what happens is actually InstaGives, he actually while doing the change in the functional test, he found that uh, we'll see just a second. He found that we are actually using invalidated block. So what invalid block does is it actually invalidates the block, which block you want to invalidate. For example, you want to invalidate this block. Okay, suppose our chain tip is this, and we want to invalidate this block. So what happens is this block is invalidated, and all the block after this block, for example, this one is the next block. Uh, if it has more blocks than
Vivek,
850.
sorry to jump in. I can't see your cursor. I don't know which block are you referring to. Yeah, I can see it now. Yeah, when you create
Okay.
boxes. Yes, yes.
Yeah. So what happens is actually suppose our node current chain tip is actually 850 003. We are at this block, and what you do is you actually invalidate this block 850 002. Then what happens is all the transactions in this block is invalidated. Basically, this block is invalidated, and all other block which is connected to this one. Okay, block that is mined after this one, all will be invalidated. I mean, your node will invalidate your peers, but your node will invalidate. All will be invalidated. So this is how the functional test. I mean, the current functional test uses to reorg to test the reorganization behavior. Okay, but this is not actually the real one. I mean, in real case, we don't actually invalidate. What we do is we actually when reorganization happen, then your peer or they might send you some longer chain, and this is how the reorganization happens in real world. I mean, in real world, no one does invalidate block or something. So that's the fix he was trying to make in this PR. Yeah, in this PR. Let me just show you that part. Yeah. So if you see here, we were actually using invalidate block to organize the chain. But after this, what we are using is we are using a fork of blocks, maybe three, maybe four, maybe nine, maybe 10. Okay. And we will submit it to our nodes. Okay. And to our nodes means the node that is doing this invalidate block. Okay. Indirect test, because functional test is all indirect test. And yeah, so let's go to the PR. This is the PR. Okay. So if you see, then uh, you might see that currently updating our other functional test, and I've just fixed this two test, and I think we can fix in this like a review club, we can fix one or more. I mean, if possible, if it takes less time, then we'll definitely. But let's go to the commits. Okay. Um, yeah, let's go to the first commit. So how we are doing that, we'll just see that. Um, okay. So if we go into this functional test framework inside test framework blocktools.py, what we are doing is we are creating a function. Okay, this will be you can say this is a helper function. This will be used by many other functional tests. So we are defining in the test framework only. So what we are doing is we are creating a function empty create empty for. Okay, so we are asking parameter as node, which node you want. Okay, I mean which in which node you want the like a chain of blocks. Okay, and the number of blocks you want. That's actually the fork length. And yeah, so we are taking the tip as the node we have received as the parameter, and we're getting the get block best block hash. I mean, with this, what we'll get is we will get the current chain tip of the block of the node. Okay, I mean the node has suppose the node has 850.003, then we'll hash is one. Okay, and this will be our tip, and height will be the block count, the current height, or you can say the 850. This is actually the height, 850.003. Yeah, and the block time, we'll just increase the block time by one. Okay, because like if if the block time is same as the previous one, then definitely the node won't validate it. So the block time should be after the previous block. Okay, the next block should be after the time should be after the previous one. So this is the list, and inside the for loop, we are just creating you can say blocks. Okay, blocks of fork length. For example, fork length is 5. So we are just creating 5 blocks. But mind it, we are not actually submitting to the node. Okay, we're just creating blocks. We are not actually submitting. That means the chain is not reorganized. First, we are just creating a block chain of blocks till fork length of size fork length, and we'll return the blocks. Blocks is basically the list. Okay, so yeah, this is the helper function inside the test framework. So what we'll do is mm, let's okay. So inside the mempool update from block, okay. So we have removed this empty fork, the helper function. Instead, we are just keeping it to the test framework so that we don't have to use the code again and again for every functional test. So code duplication we have avoided. And yeah, I mean, see, we are changing this to from self. We are just changing it to create empty fork, and create empty fork. It's been imported from the test framework inside block tools. Okay. So this was the first commit, and if we go to the next commit, that's more interesting. Yeah. I think this will be better if we'll do in VS Code. Yeah. So mempool ephemeral dust dot py. This is actually a functional test with which tests the dust and the dust limit of the transaction, various transactions. So here what we have done is we have created a constant fork length. So we have taken 10 as the fork length, and why is that so? It's because so what happens is suppose the current active chain it's just three. Okay, from this height from this chain tip, we're just three blocks. You can say we have just three extra blocks, and that's valid. Okay, and what happens is suppose this was not three, it was more than three. I mean, it was more than 10. For example, it was 11. Okay. For example, what happens is, for example, this was we had 11 blocks. Okay, from this height from 850K, we have 11 blocks away. So what happens is when we are doing chain reorganize, for example, this was not 10, this was 12, and this active chain is currently 11 blocks away from 850K, and this the four blocks that we have just uh, like calculated from this empty fork, this from this one. We have just created we have just kept the fork length as 12, and here the active chain has 11 blocks. So what happens is when we submit the 12 blocks chain, okay, what happens is this will be your active chain. Okay, so then what so all the transactions in this active chain is invalid. I mean, not invalid, but it's not actually valid, you can say. Okay, so what happens is all these transactions are uh, it's gone back to the mempool of the node. Okay, and this is only up to 10 blocks. For example, this one is the 11th block, and up till here it's 10th block. Okay, so up till 10th block, all the transactions are into the mempool, and we don't actually keep this 11th block transactions, because one reason for this is might be the transactions that this in this block, the transaction might be spending some of the transactions from the above blocks. I mean, suppose there is a transaction in 850 0003, and this 850 850 block, and this 11th block might be spending the transaction which has been mined in the previous 10th block. Okay, so if this becomes invalid, or it's into the mempool, it's not mined, then this one will automatically be invalid. So, and also other reason is actually not like bloating the mempool. Okay, mempool is stored in RAM, so we don't want the RAM to be full and node to be crashed. So we'll not be storing the 11th block transactions. So that's the main idea. And if we do actually invalidate this one, for example, if you do invalidate block of this one, then definitely this up to 11th block this transaction are getting into the mempool. So that's not the real reorg behavior. So for real reorg pattern, we'll be using fork blocks like this one instead of just invalidating this invalidate block RPC. You can say we'll not be using that because that doesn't match the real reorg pattern. That's the thing this PR is achieving. So there are lots of tests we need that needs to be updated, but for now we're just focusing on the mempool test. Okay. Yeah. Let's go to the yeah. So this is actually the function we have already talked about, and this will create list of blocks. This won't publish, but this will just create the blocks. And in um, first we are creating a constant, okay, and then what we are doing is we are creating a helper function. Again, a helper function just for this functional test. Mempool ephemeral dust.py, and that is trigger reorg. What trigger reorg does is actually it submits the block. Okay, so the four blocks, the chain of blocks that has been created with this using this function will just trigger the reorganization with this helper function. We'll see how this function is being used inside the test, but for now, just think that uh, we're just running a loop and we'll submit each block one by one. Okay, and taking the parameter as four blocks. Like four blocks is actually the block hash. Okay, the block that has been created. We'll just take the four blocks as parameter and submit one by one blocks. Okay, and so there are lots of cases. We'll not go all of this test case, but we'll just see this reorg one. Okay. So what this reorg one is doing is it's actually testing the reorg, uh, breaking the truck topology that doesn't cause issues. Okay. So we're testing the, you can say, the ephemeral dust transactions in the reorganization behavior. How does the transaction behave when there is a reorganization? So, yeah. Mhm. So, if we see in mempool ephemeral dust, we have discussed this one, okay, and we have discussed this helper function, and yeah. So, if we get inside the test and the test at line number 338, first what we are doing is we are actually creating a fork blocks. Okay, so fork blocks a list of the blocks that has been created because we are actually testing the reorganization. So first we'll just create a chain of blocks. Okay, and the node we have selected is the first node. Okay, and length is basically 10. I've already discussed why we have used 10 because after 10 the transactions are not actually inside the mempool. And also another reason is that we in history we haven't seen any chain reorganization of more than I guess two or three. And yeah, that's the main idea. And after 10, we won't have the transaction into the mempool. So basically the transaction is actually lost, or basically you can say invalidated. So first we are creating a fork of blocks. Okay. And the current chain tip is actually the chain tip of first node, the node 0. And we are testing here the ephemeral dust. The test is being done, and while you can see we have just triggered the reorg, and here we have done the reorg, and here it was I guess invalidate block. Yeah. Okay, this is not the test. Yeah, you can see before it was invalidate block. Okay, so now it's trigger reorg, and trigger reorg, what it will do is actually it will submit all the blocks that has been created using the using the create empty fork the helper function. So we'll just submit this block, and reorganization has been done because now the active chain, okay, active chain, it's actually uh, the transaction into the active chain is into the mempool, and the current active chain is actually the fork blocks, okay, that we have created using this helper function. So how we can validate this? You can see we have assert uh, keyword, and what it will do, assert mempool contents and self, and in the node we expect this dusty transactions. The transaction is into the mempool. If you see, the transaction has been mined here. Just a second. The transaction has been mined in this line. Okay, we are just using uh, generate block, and we are just mining this dusty transaction. Okay, this dusty transaction has been mined into the node 0. Now after that we are doing trigger reorg, and what happens is the transaction that has been mined should be inside the mempool, because uh, the block that the transaction was mined, it's not actually the active chain. And what happens, it should be into the mempool, and yeah, this assert mempool, this test should pass if there is chain reorganization. If there is no chain reorganization, then this test should fail. Okay, so this is how we validate that the chain reorganization has been done. So after that, what happens is we are again doing the another test case, and the another test is actually sweep transactions, and the transaction that will actually, what sweep transaction is, suppose there is a dusty transaction which has dusty transactions means the transaction which has fee rate less than the uh, minimum required fee rate. Okay, and sweep transaction is actually, suppose we have created the dusty transactions, and sweep transaction which actually spends the dusty transaction, and sweep transaction has fees way more than the required or the current fee rate. Okay, so what happens is miner would actually mine both of the transactions, because if it doesn't mine the dusty transaction, then sweep transaction is invalid because sweep transaction spends from the dusty transaction. Okay, so we are creating a sweep transaction, and it's actually spending from the dusty transaction output. Okay, then yeah, we're just creating a multi transactions, and then if you see, we have done a minimum. Okay, we have done the assert actually with that sweep transactions matches the minimum relay fee or not. Okay, and then what we're doing is we need to test again whether this sweep transactions, how does this sweep transaction behave in the reorg. So again we have to do the reorg behavior. So we have to do the fork blocks. We have to create an empty fork of 10 blocks and mine all transactions, this sweep as well as dusty transactions. Okay, and Uh, after that, we are doing reorg. And what reorg will do is actually this both transaction that has been mined into the block. This block is invalid, or you can say the chain is reorganized. So this transaction should get into the mempool. So after that, we'll just doing assert mempool contents, and the mempool should have this dusty transactions. Okay, and sweep transactions, it's actually removed because uh, it doesn't spend the minimum relay fee. Yeah, minimum relay fee is not met for the sweep transactions. And one thing I forgot is that If okay, let's show through diagram, explain through diagram. So uh, if this is the active chain, okay, all these transactions are actually mined, okay, in this active chain. But a peer send us the fork chain, which is longer than this one, more proof of work chain. And what happens is all these transactions is invalid and this gets into the mempool. And while getting into the mempool, there is mempool policies which will check whether these transactions are valid or not. Okay, so this is how the 12th block transactions are actually removed. Okay, through mempool policy. I don't actually remember the exact policy, but there is one check whether which will basically check whether this transaction has been mined 12th block, not 12th block, 11th block, or basically more than 10th block has been mined into the more than 10th block. There's a check in the mempool policy. So this mempool policy will reject this 11th block transactions. And yeah, so all of the transactions are actually validated through the mempool policy check. Okay. And yeah, again, after this test is done, we are again actually creating fork, you can say reorg behavior, and we'll create a fork, we'll test all the like I mean we'll do all the testing part and then we'll do the reorg. Okay. We do the reorg, see, we're creating a fork length, we're generating, then we are doing reorg, then after that we are checking whether this matches the expected one or not. I mean, in the real world, this matches or not. So again, in the other test, uh, should enter if dust is swept. Okay, and yeah, that's the idea. Okay, I just misconfused. Reorg transaction is basically that spends the dust transaction. Okay, and swept transactions means that spends the dust transactions, but the overall fee rate of the package, I mean the dust transaction as well as the spending of the dust transactions is more than the relay fee or the required fee. I mean this transaction is actually correct. This package is actually correct, not transaction, but package is actually correct. Sweep means it doesn't like it's not more than the required fee rate of the package. Package is actually a collection of transactions which spends the uh, previous transactions. Okay. And yeah, likewise, we are just doing all this test. And first we are setting up this empty fork. And then again, we are triggering reorg. And then we are asserting whether that transaction matches uh, the expected or the expected behavior during the reorg. Okay. So if you see, we are just creating sweep transactions and there is reorg. And the transaction that has been mined, both the transactions, and this should enter into the mempool. And mempool actually checks whether this dusty and sweep actually it matches the mempool policy or not. So they matches the mempool policy, and that's why they are inside the mempool. We're doing that check through this function. And yeah, this was it. So if we get into the PR, mm, yeah, instead of invalidate block, we're just using this helper function, trigger reorg. And again, uh, there is also a function reconsider block. So reconsider block, what it does is actually a block that has been invalid. Okay. For example, this block, you have made this block as invalid. Okay. Now you can reconsider this block. Okay. So when you invalid this block, all the next block that has been mined, all the blocks that has been mined after this block will be invalid. Okay. because this all these blocks depends upon this one. And when do you invalidate? When do you invalidate, all of this becomes invalid. So when you reconsider this, doesn't mean this will get this will again be reconsidered. Okay, so reconsider block doesn't mean that all this block will be valid. So you have to like keep the hash of all this block to do reconsider block, reconsider block. So that was the main thing lacking in in the um, current test. Okay, so um, so next thing is so what this reconsider block RPC was doing was it was actually cleaning up the mempool. So for the next test, for the next test, for this next test, we this one this is the next test. For this next test, we want the mempool to be cleared. So the cleaning of mempool was done using reconsider block. So there was a big flaw with this method is that reconsider block doesn't mean suppose transaction has been mined in this block. So reconsider block of this block doesn't mean the transaction that is in mined here will be again like cleaned from the mempool. Okay, because we are not reconsidering this block, we're just reconsidering this block. So that was the main flaw. But I mean, in the current test, we are actually not reorganizing more than one block. Okay, so I mean, this is actually not a bug or a flaw in this test, but we shouldn't use this reconsider block. But instead, what we'll do is we'll just use generate block, and the mempool is cleaned. Okay, and then we are again doing the another test. We are creating a fork of blocks. Then we are generating the block and triggering reorg and asserting whether that matches with the behavior of the reorganization or not. That was the uh, idea behind why this was changed. Yeah, similar way mempool packages as well. We are doing again like a helper function. I mean, I was thinking this trigger helper function could be inside the test framework. Let's see if we have more than many uh, test which uses reorg. Okay, so we can keep this inside the test framework so that we don't have to duplicate code again and again. So yeah, that was it. So what we'll do is we have time. So what we'll do is we'll just go through one of the tests and change the the reorg pattern. Okay, so let's see which test uses uh, reorg. Okay. Mm, okay. Okay. Feature about. Okay, this test is quite big. We'll not go through this. Uh, this one is shorter. Uh, let's see other one. Oh, this is also quite big. Let's do actually one of the test that's in my PR. I mean, okay. So if you have any question, you can just interrupt me and ask. Uh, let's see. Mempool resurrect. Mm,
I just start. I don't have any questions, but mempool packages. If you could talk a little about it, I know about mempool policy, but what exactly is mempool packages?
okay, mempool packages, right? So in mempool packages, as far as I know, we are actually testing whether the parent transactions and the descendant transactions, whether they are matching the real test with a real case of the Bitcoin core, okay, with this functional test. So we'll see what we are actually testing here. Okay. So yeah, likewise, we are just first of all, we are just creating fork length, okay, and then a helper function for reorganization, and then we are testing whether the default ancestor limit, I think it's 25. Yeah, it's 25, and descendant limit is also 25. So ancestor means the transaction that you are spending from. I mean, suppose you are spending a transaction, then that transaction, the previous transaction becomes your ancestor, and the transaction that spends your output will be your descendant. Okay. So in a package is basically a collection of transactions. So in a package, the ancestor of this transaction shouldn't be more than 25. That's the default. That's the mempool policy limit, and the descendant shouldn't be more than 25. So I think this is the test we are. This is the case that we are testing in this functional test, as far as I remember. So if you see default ancestor limit transactions of confirmed transaction should be fine. Okay. So we are creating a chain of transactions. I think the chain length is 25. Yeah. We see the nth transactions. Okay. So basically, we are creating a chain of transactions. The nth transaction is pending the n minus one transactions, and n plus one transactions is actually pending the nth transactions. Yeah. Parent of, yeah. So yeah, we are creating a witness chain, and ancestor size, phase. Um, so the transactions that we have created. Okay, we are actually creating a transaction here, and then we are sending the transaction to all our peers. Okay, not peers, but to this node. Okay, okay. Mm, 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 mm. Before sending the transaction, we are just doing inv and get data, because we want to see whether that node is reachable or not. We're doing that, and then so we'll check whether that mempool has a default ancestor limit, that's 25. So what we are doing is, in the node, we'll see whether get raw mempool. Okay, get raw mempool. I guess it gives the contents of the mempool. I mean, the mempool has, or the number of transactions it has in the mempool. So we're asserting the length of the mempool with ancestor limit. So if that passes, then that means the node has the limit of the ancestor. Yeah. And the next thing, okay, the ancestor v size, which we have calculated from here. I mean, the each transactions we are for each transaction we are calculating the ancestor size, and yeah, ancestor size is actually list. Ancestor fees actually is a list of the each and individual transaction, and ancestor fees whether it matches the mempool the transactions. And yeah, so basically we are testing whether this mempool, the ancestor fees and the fees given by the mempool matches or not. If that matches, then we can assume that we can not assume we can confirm that the mempool has the transaction that we have just sent. Okay, with this function, we are send first we are creating a transaction of mempool packages, and then we are sending it to that node. Okay, and we'll check whether the fees that was calculated here, the fees and size of the ancestor, whether it matches with the mempool calculation or not. That's what we are doing. So this assert, uh, uh, is that assert? Yeah, this assert does that. After that, mm, so if you see, then the mempool already has 25 transactions, 25 ancestor and 25 descendants. Then now what we are doing is we are again creating a transaction. Okay, and that will actually spend. Chain means the transaction, the chain of transaction from the packages. So it's pending from that. Okay, we are just creating a transaction. That's the next hop. This is actually a transaction. Okay, so now we'll assert whether this chain chain yeah. So next hop is a chain. Okay, next hop is a chain, and whether this chain is actually uh, like matching the mempool limit or not, because we are again spending from the chain uh, the last descendants, you can say. We're spending from that. So if we see, then the number of descendants is actually 26. Okay, because we have created transaction, and the mempool should reject, and the rejection should be that the chain is too long, because we have 25 as the descendants as well as the ancestor limit. So yeah, this was the case for, I guess, ancestor, and this one is for descendants. Okay. Yeah. If you see here, then we are just checking the descendant count, and descendant count and fees and size likewise. Okay, the real assertion is here. Ancestor calculations and all that stuff. I mean, this will take a lot of time. I mean, you have to stay for, I guess, 1 more hour to see what this actually test is. So if you see, then the main idea is whether this reorg pattern has been tested here or not. Yeah. So yeah, reorg is there. So likewise, we're just creating fork blocks, empty fork, and the mempool contents of the first node, where we are taking into the mempool 0, and we'll be generating a block, and then we'll do the reorg. Then what is this mempool before generating this mempool content should match after reorganization. Okay, after reorganization, what happens is the transaction that has been mined here will again get back to the mempool. Okay, so this assert should match. That's why we are doing this assert, and again we are cleaning up the mempool. And after that, what we are doing is we are creating a package of transactions. Okay, this is the transaction, zeroth transaction. Transaction 1 is actually spending from transaction 0. Likewise, transaction 2 is also spending from one of the outputs of transaction 0. 3 is spending of from 2, 4 is 3, 4 from 3, and 5 likewise. And mind all these packages in the next block. Okay, and I guess this here it mines all the transaction, this transactions, or you can say package. And what we are doing is we are actually creating a fork. Okay, so yeah, so I think basically we are testing how does this package behave in the reorganization. Okay, first we are again likewise creating an empty fork, and we are creating a transaction 0 that has two outputs. Okay, because we want two outputs. One should be spent by transaction 1 and the other should be spent by transaction 2. So transaction 1 spends from the 0th vout and transaction 2 spends from the first vout. Okay, so this actually creates a chain of transactions. Okay, and this also helper function. This creates a chain of transactions and mines all this package into a block. And what we are doing is, okay, we are generating a transaction 8 with a fee more than, I mean, with a big fee. Okay, so we'll sync the mempool between the two nodes. In this case, we are using actually two nodes. We'll sync both of the nodes mempool, and then we'll do the reorganization. So what we'll do is reorganize the mm, node 1. We'll do the reorganization from of node 1, and again we'll do the reorganization of node second node. Okay, so I think what we can do is we don't have to do this. Mm, yeah, I think we don't have to. We don't need this because after that we're just using this sync blocks. So this will actually sync the reorganization of both the uh, node. Okay, so if this node is been reorganized, it has more proof of work chain, and with this function, it will also send the blocks to the node that this node has been connected to its peer, basically. Yeah. Okay, what I'll do is I'll just keep this for review. I mean, if you guys want to review, you can just review. And what we'll do is we'll go through this test. Okay. We'll just implement reorganization pattern here. So if you see, this one is pretty, I think, small. So we're creating three block 1, 2, 3, and Coinbase transactions. Uh, okay, we are creating three transactions that spends from this 1, 2, 3 Coinbase, and spending that spends. Okay, and mine another block, invalidate both the blocks, and make sure that the mempool has the transaction that has been mined in the block. I think that's the behavior. Mhm. Okay. Yeah. Yeah. So we are creating three blocks uh, and pending the transaction of the Coinbase transactions. Okay. And spending is mined in a block. Invalidating it. Invalidating basically means the organization. So in the organization, it should get back to the mempool. Okay. And we're just validating that, and again mine a block to clear the mempool. Okay, that's the main idea. So we'll see. Okay, we have the block list, and yeah, okay. So this is the first transaction, and this one is the second transaction, and we'll generate uh, a block um, in the first node. Okay, so we have only one node in the node, and spend the transaction, and then that this transaction should be spend transaction should be inside the mempool. Okay. Then generate another block to clear up the mempool. Yeah. So I think for this, what we'll do is we'll just simply like copy from this, not copy, but like a match with this behavior, the mempool formal test, because this test has been reviewed. Okay, so I feel confident like matching similar behavior with this test. So first we'll just take this fork length, and then we need a helper function. Mm, okay, we'll just copy from here. Yeah. So this is the helper function. Okay, and next what we'll do is okay, so basically what we are doing is actually we have three blocks. Okay, it is 1, 2, 3, and we are actually spending the Coinbase of block 1, 2, 3. Okay, and that's what we are testing here. So uh, if you see, we are just creating a transaction here, and next what we'll do is we can just create a fork block, create an empty fork. Okay, so empty fork has parameter node and fork length. Okay. Okay. And then we just created a fork of blocks of length 10, and the transaction has been created. Okay, and I think this should be after this. Mm, yeah. So we're just creating an empty fork from the current chain tip. Okay. So yeah, the mempool should be empty now because we are not generating any block. And mm, mm, mm. Okay, Okay, so we need to create a fork before this generate, because we don't want, because we actually want to see how this behave in reorganization. This is actually a test. Yeah, sure. Thanks for joining. And yeah, we are just creating a fork of blocks. Now, what we'll do is, this is the test scenario, and this assertion should pass because all the transaction has been mined in the next block. And if you see the confirmed transactions, okay. Uh, so this is the reorganizing. We are doing reorganization here. So what we'll do is we'll just reorg here, and here we need to pass for block. Yeah. So we'll not use invalidate here. Let's update this command to trigger reorg. Mhm. Okay. So let's test this. Yeah, the test passes, but let's validate one more time. Yeah, we have a block of list. Okay, and we're spending from first Coinbase transaction, and then second transaction spends from second Coinbase. Then spend IDs is the set of the both spend transaction for that, and we'll assert whether this mempool is empty because, yeah, because block has been mined, and then okay, the current block should have both the transaction. Yeah. Uh, so with this assertion, we are now testing whether this transaction into the are into the mined blocks. Yeah. So we're just triggering a reorg. Then what happens is all the transactions should be inside the mempool. The mempool should give spend IDs. Spend IDs is both this transaction. Both these transactions are invalid. Not invalid, but I mean it's not in the current chain. It's not mined into the current chain. So yeah. So we are just reorganizing here and should be back. Generating another block because this transaction that is again into the mempool should be mined. I don't know why this test is here. So maybe cleaning up the mempool. Okay. Okay, this transaction has been mined. So we'll see whether this transaction is mined again or not in the next block. So yeah, we're just mining and asserting. Yeah. Yeah, I mean, this one is easy. So let me check. Uh, okay, this one is fine. Hmm. So we can just remove this. empty space. Okay, so one more important thing is that suppose your cursor is here and you are just pressing a tab. So this creates a space. So in Bitcoin Core, if there is an empty space, then definitely you'll fail the lint or basically the CI test. So mind that as well. We need to check that. Okay, okay, let's not touch this one. If there is already a space, then let's not remove that space. So instead of invalidate, we are just using this helper function. I think this one is fine. Yeah. So what we'll do is we'll check commit. So we'll give this change in the new commit. Okay. First, we'll just reset, soft reset. And then what we'll do is the first commit is basically the helper function. Okay. The second commit is the real one where we'll have all the mempool test. Yeah. Mm, let's commit this. Okay. So let's push, I think. So we have ephemeral dust. Should have the resurrect one. Yeah, we have the resurrect one. Yeah, that was it. So if you have any question, you can feel free to ask me.
Yeah, so I was wondering, since there is a fork length for 10, and after
Yeah.
that the all the way not mine, I was wondering in invalidate block, if I invalidate say is that 850K block, uh, how many blocks deep down it will it go to check for a side chain, or like a possible side chain that could be the new active chain, because like there should be a definite number, since a lot, if I go a lot back in the chain, then it doesn't make sense, because uh, uh, a side chain that is too far in the that is too far in the past created won't be able to be sustained by any attacker if he would have tried to maintain one. Like, it is not worth it to have a side chain that is that is too far in the past. But it could be the case that, like, say, at the 25th block, 25, like 25 block behind, there is a sidechain that has more proof of work, and like a node is maintaining that. Like, I just want to know a definite number, like how deep into the chain the that like that the invalid after the invalidation will we go to check if there is a possible side chain or not.
Okay. So basically, you are asking that how many blocks in the past will the chain reorganization occur? You're asking
Yeah,
that?
I'm asking, like we will look for possible side chains that could become a become the new active chain,
Active
right?
chain.
So
Yeah.
there can be a lot of reorgs. Like the reorg could happen from any block that is like, let's say I invalidated 850K block, but the reorg happened
Yeah.
25 blocks behind, like something of that scenario. How long will it look for it? Because there could be two reorgs, right? There could be another sidechain that is from like the 10 block behind. That could be the case. But the so let's say the reorg that the next chain caused us, next the peer node caused us is happening at the 25th block, like 25 block behind the block we invalidated. Like in the real scenario, there would be no invalidated block, but like how far will we go to check if there is a side chain that is a possible candidate for active chain?
Okay. As as far as I know, there is no check for that. I mean, but there was a checkpoint. There was a checkpoint. But I think that has been removed.
Like
Uh,
the first part of the invalidate block function is to check for possible side chains. It is by getting like taking in all the member or all the possible blocks and storing them in the hash, and then looking for what could be the possible new tip.
hmm.
I don't know
uh,
how far does it like go in the traversal.
I mean, and if if the block, for example, you're asking that what if there was a chain reorganization before this 850K blocks,
Like there
and
multiple scenario where there is a side chain at say 15 blocks behind, the reorg
yeah,
happening at 10 blocks.
okay, okay. So there is no check. I don't think there is any check, and there was a checkpoint, but that was being removed by Nicholas, not Nicholas, Markov Leon, as far I remember. He in the recent uh,
Uh,
PR, he actually removed the checkpoint. But what does that mean? It's that if you can submit a chain, okay, chain which has more proof of work, and that is beyond this 850K. I mean, past this 850K. That is, for example, just sending for example, you are sending you can say a fork of chain at suppose blocks 250K. Okay.
no.
You might send a fork of chain in this block, but if that chain is valid, I mean, node validates it. If that chain is valid, that means this the it and it has more proof of work, then that means this chain will be considered. And till now, all the transactions that is in mind will be rejected. That will be again invalid, you can say. So all of the bitcoins you have, that will be invalid basically. So this chain, the new chain, will be considered as valid. Before this PR, we had a checkpoint at certain height. Uh, uh, Marco. There was a PR. As far I remember, the checklist was, yeah. the checkpoints. The checkpoint was removed. And in version 30, the Bitcoin Core version 30, we will not be having any checkpoints. This here the checkpoints was removed. So basically, now if you have a longer chain, then that has more proof of work, then definitely this chain will be considered valid. And all the transactions and all the Bitcoins will be invalid now. I don't think so that will happen because you will need uh, more than 50%
Yeah,
hash rate current. Yeah, but that's not practically it's not possible. Theoretically, it might be possible, but practically, it's very difficult. Yeah, that's and the it's like suppose fork length 10 is taken because suppose this length is 11th, and if this chain is not active, then all this transaction gets into the mempool up till 10th block. Okay, not past 10th block. So, for example, here is a 11th block, and if you submit a chain of suppose block, then this will be active chain, but only transaction up till 10th block will be getting to the mempool. That's the mempool check, mempool policy, and yeah, that's the mempool policy. That's not consensus policy. That's it. So, any other question?
none from me.
Uh, yeah. So then let's go to the question. So, yeah, this one is pretty easy. What do you mean by reorg in Bitcoin? Anyone wants to try?
Since when the peer node sends us a different chain and will different chain from the what we have, so we'll take on the new blocks that the chain is offering. We will take them and we'll rebuild our chain according to that. And all the rejected blocks now will their transactions will be like put into the mempool only for 10 blocks. Other than that, they would be not added into the mempool.
Yeah, yeah. Uh, yeah, the chain should have more proof of work. Yeah, cumulative proof of work. Yeah. And how does Bitcoin Core handle reorg? I mean, this is actually more kind of philosophical or theoretical question. It's not code related. Code related, it's very like uh, it's very long and it will take around 5 to 10 hours. I've seen that code. It's actually activate best chain. This something like that. This will take more than a week. I mean, the code is very long and you have to do that. So yeah, I mean, if it has more than if it has more proof of work blocks, and if that blocks are valid, then it acts as the current active chain. So this question, what were the challenges with the test for reorg patterns? I mean, previously, what was the challenges? Anyone wants
So
to try?
it was not the real behavior, like we won't be invalidating block in a real-time scenario, and we'll be getting a new chain that the other node is offering. The other node will not request us to invalidate a particular block and form a new chain and reorg it.
I think we also using reconsider block RPC, which is not good.
Mhm. Yeah, yeah. I mean, it doesn't matches the real reorg pattern. So, and the next is why using fork length as 10 matches the reorg pattern. Anyone wants to try?
because of
Okay.
the test cases, like the controlled behavior written in test cases allow us to hard code the number 10.
I mean, since like more than 10 reorg, if 10 more than 10 block reorg happens, then it's not going into the mempool. The transaction are not going into the mempool, so there is no use of keeping more than 10. 10 is the worst case limit, and after 10, I mean, if we can keep 11, but that doesn't make sense because there might be, we don't want to reorg. I mean, in the test, we might not be reorging more than 10 blocks.
I have
So
a
I mean,
question.
because that is, yeah,
Okay, so this is the same behavior we are using in mainnet also, the 10 block.
yeah, 10
Okay,
blocks.
okay.
It's the mempool policy. I mean, the transactions, the reorg transactions into the other blocks that has been mined and the chain that has been reorged. If the transaction gets into mempool, there is a mempool policy that checks whether the transactions is uh, in the 10 block range. If it's not, then it's invalid. I mean, it's not. It's flushed from the mempool. I mean, it's not kept into the mempool. So that's the mempool policy.
Yeah, it also makes sense since we can't be adding a lot of transactions in the mempool. We would want a mempool to have
Yeah,
mempool
right.
is has a limited space, and we
Yeah,
can't.
Yeah,
mempool is different for everyone.
Yeah, so it doesn't matter if we don't have the other transactions. We would be preferring any transactions that is beneficial for in the fee scenario. We'll be getting more fees.
Yeah.
yeah, makes sense. So yeah, this was it. So I think we can end this session.